for the masses began with vision from our forefathers with the establishment of the Faculty of Medicine at Chulalongkorn University in 1947. For over 7 decades, MDCU has been home to the country's most innovative medical and scientific researchers. Paving the way for medical excellence and to offer adequate and accessible health care to all mankind, we have made daring efforts to develop and promote medical breakthroughs ranging from HIV, rabies, tropical diseases, family planning, and sexual reproductive health for women and adolescents, to the latest breakthroughs in cancer, genomics, and rare genetic diseases, reaching to the COVID-19 pandemic. We, at the Graduate School of Global Health at the Faculty of Medicine, Chulalongkorn University, capitalize on our proven depth of expertise in each respective field to prepare future leaders for global health challenges. The unique courses and modules offer medical, healthcare, and public health professionals from around the world a tailored approach to the latest global health and public policy disciplines. Global health perspectives are cultivated and delivered from a local and regional vantage point to help promote health equity and accessibility, as well as to reduce the economic and infrastructural burden of healthcare in developing nations. Together, we can build new healthcare systems to support the increasing demands of the 21st century. At the Graduate School of Global Health at the Faculty of Medicine, Chulalongkorn University, we care with our broad vision. We dare by doing, and we share our expertise with the rest of the world. Join us today.
Good afternoon, ladies and gentlemen. On behalf of the School of Global Health, Faculty of Medicine, Chulalongkorn University, I'm really honored and pleased to welcome all of you to this SGH Forum. As we know that the endocrine disrupting chemical is one of the global health threat and concern. Previous study alarm us the linkage between EDC and some particular diseases. Today, we will learn from our expert in this field. And we hope that after this forum, we can identify the working group in these regions or across the regions and work closely and explore more widely on the research of EDC and human health. Finally, I would like to thank all speakers for sharing your experience in this forum, and of course, all participants who joined this webinar. I will hand over this section to Professor Vichit for running the forum. Professor Vichit Suphonsinchai is a professor of pediatrics and the head of the Division of Endocrinology, Department of Pediatrics, Chulalongkorn University. He has published more than 40 research articles in the area of pediatrics endocrinology, including EDC. And his research interests are focused on the EDC exposure and associated studies between EDC and common pediatric endocrine diseases. Please welcome Professor Vichit Suphonsinchai.
Thank you very much for kind introduction, and good afternoon, ladies and gentlemen. And thank you again for joining us for the meeting entitled Global Concern on EDC and Way Forward. Today, I will be a moderator of the meeting. We will have a tea session by 3 speakers. So I would like to introduce the first speaker. Okay. Okay. The first speaker is Professor Kyo Ho Che from South Korea. He is a professor of environmental toxicology in Graduate School of Public Health, Seoul National University. He is a director of Institute of Environment and Health and director of BK Center for Sustainable Health and Environment. He published more than 200 articles in the area of environmental toxicology, exposure risk assessment, environmental epidemiology. And his research interests are focusing on identifying adverse health effects of EDC in human population and elucidating underlying mechanism in the experimental studies. He is also an editorial board member of several academic journals, including Environmental International, Environmental Science and Toxicology Letter, and Environmental Toxicology Chemistry. And now he is the Vice President of Korean Society of Environmental Health. So please welcome Professor Che.
Thank you very much for your kind introduction. My name is Kyung-ho Che, Sawadee. I'm very happy to join this seminar, and I really hope that this can be the start of our collaboration on this important area of endocrine disrupting chemical and children's health. So let me just start my presentation by sharing the file. Can you see the presentation mode?
Yes.
Okay, so yeah, the title of my topic is about a general introduction to endocrine disrupting chemicals. And I mean, the reason we think these compounds are important in public health. And also, I would like to talk about how we can address these kinds of problems in this society together. First of all, I have to talk about an increasing instance or prevalence of male and female reproduction-related disease. As you can see in here, there are increase of semen malformation over the time. And in Korea, we have seen an increased instance or prevalence of female reproductive disease like myoma or endometriosis. And also increase of obesity and neurological disorders world phenomenon. We see gradual increase of obesity, mostly in OECD countries and other countries as well. And also we see gradual increase.
Sorry to interrupt. I'm not sure the slide is running.
Okay, so.
Yeah, and please, just turn to the full screen, please.
Okay. Can you now see can you see the full screen?
We couldn't see your slide.
Ah. How about now? Can you see this slide?
Yes, you can see that. I can see.
Can you see this slide?
Yes, we can.
Okay, thank you. I mean, I used to use a dual monitor, but this time I have to use my laptop only. So yeah, sorry about this problem. let's get back to the previous slide. So we are seeing, kept seeing increasing trend of obesity and neurological disorders worldwide. Many of us are thinking that chemicals may be responsible for this increase of disease. For example, congenital hypothyroidism in the USA, the increasing pattern exactly overlap with some of those chemical use. For example, like organophosphate chemicals, things like that. I think there is some problem with my slide, but it's not very important for this presentation, so I will just skip this. And there are many diseases classified as endocrine disrupting chemical related disease. American Society of Endocrinology identified these 6 diseases as a kinds of disease that are related to endocrine disrupting chemicals like obesity, diabetes, female-male reproductive system, hormone-sensitive cancers, prostate gland, thyroid hormone, and neurological neuroendocrine effect. All of these diseases are associated in one way or another with chemical exposure. And because of this chemical exposure, the disease burden cause a serious financial burden to our society. Many people estimate the societal burden of EDCs in terms of like public health burden. In Europe, it costs annually $340 billion a year. And in China, the disease burden amount to about 1.1% of GDP. So it's not a small amount of money, but in addition to this financial burden, like health burden is very serious, and that is really a serious tragedy for the family who are affected by this EDC exposure. That's why EDC was classified as emerging policy issue from ICCM, International Conference for Chemical Management. But the problem with EDC is EDCs are everywhere in our daily lives. For example, some chemicals existing in food and drink containers like phthalate, bisphenols, PFAS, and cosmetics, pharmaceuticals, personal care products, consumer products, and biocide all include different types of chemicals that could disrupt endocrine system of our body. But because we have so many chemicals we are using every day, it is pretty difficult to associate with the use of chemical with the endocrine disrupting disorders. So one way we can do is epidemiological evaluation. So by running association studies, we can identify some chemicals that are responsible for endocrine disrupting disorders. So I'm going to show you some of the examples we have been doing in Korea. For example, we use a public database from USA. We found that some chemicals like BP3, I guess BP3 is a familiar name to many Thai people because Thai is one of the first government which banned the use of Benzophenone 3 or BP3 in sunscreen because this BP3 could kill the coral reef. So we found that BP3 and bisphenol A and DEHP metabolite in some way or another with thyroid hormone disruption. For example, increasing urinary BP3 metabolites and DEHP metabolites are associated with decreased thyroid hormones. Recently, in a big study which used a pooled data from 16 US birth cohort, with the subject number greater than 6,000, this study found that phthalate exposure during pregnancy may be a risk factor for preterm delivery. There are several phthalates that are significantly associated with preterm birth. And we found in Korean mothers that if you are exposed to certain chemicals like DEHP or mercury or PCB, we would see our offspring in having some neurological disorders or low neurodevelopmental scores based on Bailey scale. These kinds of epidemiological evidences are plenty. We can find similar observations in everywhere. And in order to support our observation, we need to have some kinds of mechanistic. For example, if we find some of these epidemiological observations by running some experimental studies, we can provide biological plausibility for the observation we found from the human population. I'm going to show you some of those examples we and other labs are using in order to support the evidence of association we found in human population. For example, following the exposure to DEHP for 6-day exposure in zebrafish, we see some changes in thyroid hormone levels in dose-dependent manner. And this thyroid hormone disruption was accompanied, coming together with some changes in gene transcript like T thyroid stimulating hormone or sodium iodine synthetase. All of these transcripts are responsible for thyroid hormone homeostasis. So we have some experimental evidence that support that DEHP has something to do with disruption of central regulation or synthesis of thyroid hormone in the body, in the fish. We also found that Benzophenone, the UV filter, can disrupt thyroid hormone homeostasis in pituitary gland and also thyroid follicle cell. We see some transcriptional changes by the exposure to these chemicals. And when we expose this chemical to the fish, we found some decrease of thyroid hormone levels like T3 or T4, which is similar to the observation we found from the human population. And from bisphenol and also bisphenol A analogs, when we expose these chemicals, the zebrafish to these chemicals, we see some changes in thyroid hormone levels in the fish. And also we found some transcriptional changes in key genes in different organs of our body, like brain, pituitary, hypothalamus, and thyroid gland itself, and in circulation. So these examples clearly show that some of these consumer chemicals in experimental animal can influence a hormone homeostasis, and that could eventually affect the balance of thyroid hormone, which were also found in human population. And some of these chemicals are also associated with behavioral changes. When we expose them with these UV sunblocks, we see some behavioral changes of the fish. This is a kind of like a result from the behavioral assay using zebrafish. We found dose-dependent decrease of those behavior when we expose them to a UV filters. And also we found some significant transcriptional changes of the genes associated with neurogenesis or like neurological marker genes. So by having these kinds of information, evidence, we can support that these chemicals may have something to do with behavioral changes or neurological disorders we used to see in human observational studies. So basically, using these kinds of information like epidemiological observation and also toxicological support, we are convinced that some of these chemicals are actually disrupting our endocrine system. But our task would be then, which chemical in our daily lives are most important determinant of endocrine disruption in humans? So in other words, we have to identify among so many different types of endocrine disrupting chemicals, which chemical would be most important target chemical our society try to reduce its exposure. So for that purpose, I think, I would put it in this way: how would we identify priority chemical, most important chemicals? And one way of doing that is to compare the exposure levels of certain chemicals among different countries. This is an example for parabens. And we Koreans are exposed to very high levels of ethyl paraben compared to other countries like Europe and USA. As you can see here, in different age groups, we found Korean children, infant, adolescent, or adults are exposed to very high levels of ethyl paraben than other countries. And that kind of finding alarm us that there must be some specific source of ethyl paraben, very specific to Korean only, so that we have very high levels of ethyl paraben. So in order to identify and confirm the presence of such source, we can design a kind of intervention study. So by intervene certain source we believe important, and after the intervention, by observing the levels of exposure in our body, we can make sure that this source is responsible for the exposure to that chemical. For example, if we believe that ethyl paraben is exposed by personal care product or diet, then we intervene the personal care product first, and then later cosmetics and personal care product first, and then later we intervene a dietary component. And we collect the urine sample before intervention, after first intervention, after second intervention, and after getting back to normal. And by comparing baseline after first intervention, after second intervention, and after getting back to normal, by that comparison, we can say that which component may be responsible for exposure to certain chemical to certain extent. For example, we recently published one small study where we intervene mother and baby pair for canned food, plastic packaging food, and also fast food or delivery food for 3 days. After these 3 days of dietary intervention, we compare the levels of urinary bisphenols before and after the intervention. And we found overall about 30 to 40% of reduction of urinary bisphenol A secretion, which means that these intervened dietary factors may be responsible on average about 40% of bisphenol A exposure. But for certain people, there was no decrease, but increase of urinary bisphenol concentration in 8 people. So these kinds of observation emphasize that there must be some other major source of these bisphenols among those people. So by these kinds of exercise intervention study, we can identify which source are important contributors of exposure to certain chemical and how much responsible for that in terms of the extent of exposure how much important is that source. This is another example done by Taiwanese people. These researchers ask Taiwanese girls change their behavior, hand washing, or use of plastic cup, or use of shower gel. So if you hand wash more, and if you use less shampoo, then they found in their urine MVP, which is one of those frequently used phthalate, decrease. So by looking at these kinds of observation, we can see that, for example, MVP exposure is to a certain extent can be explained by something in your hand or something in your shampoo. So by this kind of practice, we can identify major sources of certain chemicals. So basically what I'm trying to say is there must be some important chemicals in our society that is most important in terms of endocrine disrupting effect. And our task would be to identify which chemical is most important determinant of endocrine disruption in our society. But this kinds of exercise is not done that much around the world. For example, the countries like China, Korea, and Japan, there are many studies already done in terms of biomonitoring, how much of these endocrine disrupting chemicals are existing in our urine, for example. But in countries like Thailand, up to like several months ago, I checked this data, and I found only 2 studies published for bisphenol, and I'm sure it's going to be increasing because of the work by Professor Bichit and Chulalongkorn University researchers. But compared to other countries, actually there are very limited studies published in these countries like Indonesia, Bangladesh, and Egypt. So which means that we do not know how much endocrine disrupting chemicals are actually exposed among the people of this region. So I have to say that the current status of exposure to EDCs are still in black box in many countries, including Thailand. We have recently conducted a comparison study among different countries. We found, when we compare the phthalate and pesticides concentration among the children of Saudi Arabia, Thailand, and Indonesia, we found, luckily, Thai children are least exposed to DEHPs and other pesticides. But the Saudi children are exposed to very high levels of conventional pesticides like DEHP and some replacing alternative pesticides like DEHTP. So by looking at these kinds of data, we can tell that Thai children are relatively safer than other children, but Saudi children and Indonesian children are exposed to high levels of DEHP, and Saudi children are exposed to high levels of DEHTP, which teach us what kinds of target chemicals should be studied in the near future for these children. Because Saudi children are exposed to very high levels of phthalate, we compared the levels with other reported data, and we also found that some of those conventional phthalate are very, very high among Saudi children. This red bar indicates Saudi children urinary level, and the blue bars are from the literature, similar aged children. So as you can see in here, MNBP was number 1 and compared to other children. So which means that there must be some very special exposure source for those Saudi children. And this is the topic we need to study right away in order to reduce the children's exposure to chemicals. This is another example. We conduct comparison study. We collect the urine of Thai pregnant women and also Korean pregnant women. And when we compared the levels of some alternative new plasticizers, we found Thai women were exposed to higher level. As you can see in here, we see star. So statistically significantly higher levels of certain chemicals like ment, MEOHP, MEHHP metabolites higher than Korean people. So for some reason, Thai women are exposed to higher levels of phthalates, especially during pregnancy, compared to Korean people, which means we need to do some study to identify source of exposure to these chemicals among Thai ladies. So we believe that international comparison is very important. By comparing multiple countries with the same study design, we can identify which chemicals are more important among specific reason. So these days we design international comparison studies forming Asian Biospecimen Bank. We have a colleague in Thailand, Indonesia, Bangladesh, Saudi Arabia, and Egypt. And we use the same study design to collect urine samples from early teenager children and compare the levels of specific endocrine disrupting chemicals so that we can understand which chemicals are more important in some area. So this is my last slide. So in this short introduction, I try to show you that EDCs are among the major modifiable risk factors of many chronic diseases, including children and adults. And by identifying priority EDCs, we can do something to mitigate the damages from endocrine disrupting chemical. And identification of priority EDCs can be done by association studies with endocrine disease in certain countries. And also we can conduct biomonitoring study to see which chemicals is extremely, relatively high in a certain region. And in that sense, I believe that exposure assessment is the first step toward the solution. By conducting exposure assessment, we can identify possibly major source of certain chemical exposure. And also we can identify vulnerable population from which we should find some way to reduce the exposure to endocrine disrupting chemicals. Okay, with that, let me just wrap up my presentation and thank you very much for your attention.
Thank you very much, Professor Che. It's a very interesting session. And next session, I will share the data from Thailand, especially in Thai children. Can you see my slide? Yes.
It is not a presentation mode.
Okay. So wait a minute. Okay, full screen already. I will share you the EDC data in Thai children that we have now. Okay, this is the overview of my talk today. I will start with talking about general consideration about EDC. This is back to the basic a little bit. And our study focusing on two most common EDC that we found in our life. That is bisphenol A or BPA and PHTHALATE. For the study that we have done, we study in two aspects. The first one is about exposure or detection frequency of the EDC, and the second aspect of the study is an association study. We study some EDC with common pediatric endocrine problem, for example, precocious puberty, obesity, body composition, and type 1 diabetes. For the definition of EDC, actually there is no universal definition, but the most widely accepted definition given by the WHO and IPCS, that stands for International Program on Chemical Safety. They define EDC as exogenous substance or mixture that alters function of endocrine system and consequently causes adverse health effect in an intact organism, its progeny and subpopulation. This is a route to export EDC. The most common route to export this EDC is by ingestion, but we can export EDC by inhalation, dermal absorption, through a breastfeeding, or even from the mother when you are a fetus. But important is the timing of exposure is very important for the change in the future. Before we go into detail of EDC study, we have to know about some difficulty or limitation or research on EDC, because it's difficult to translate what happened in wildlife to human because we are in different system. And as I mentioned before, the age at exposure is very important because in third uterine life is the most critical period to expose to EDC. And disrupting effect of EDC may not be a dose dependent. This means that when you expose low dose, maybe have some more effect than higher dose. And EDCs can have a latency period. This means that they have a time lag between EDC exposure and disease outcome. This is make us very difficult to conclude the study. And this picture shows that when you are exposed to EDC during the fetus, and the disease outcome will occur anytime in your life. This the mechanism by this is explained by epigenetic programming. And some more difficulty and limitation on the research of EDC is the picture effect. Because in human, we are normally exposed to different EDC over time to a mixture that rather than single compound. And the same EDC may cause both agonist or antagonist in the same receptor or pathway. And the most important is EDC have transgenerational effect by epigenetic mechanism. This means that if your parent have some abnormality from EDC exposure, they can transfer to their sibling who have never exposed to that chemical. This is very important for the research on EDC. And for the chemical that are thought to act as EDC shown in the slide, but this is just a tip of iceberg because there are several substances in the environment waiting for determining whether they are EDC or not. So we just pick up the common that I mentioned before to study, that is BPA and phthalates. Bisphenol A or BPA, we can find in polycarbonate plastic. That is a recycling code number 7 that can be found in medical device, dental sealants, feeding bottle, and toys. And we can find BPA in the can product because BPA is in the inner lining of the cans that contain many products in the market. And we also find the bisphenol A in thermal paper product, for example, receipt. For the phthalates is one of plasticizer. Phthalates is a group of metabolites. It can be di or monoform. And normally phthalates was used to make a plastic to be flexible and harder to break. And phthalates can lubricate other substances and make and penetrate and soften the skin. So we can find phthalate in lotion. And phthalates also used to help fragrance in perfume to be last longer. And this is important because phthalates are not chemically bound to the plastic tightly, because so this make phthalates will shed out in the air, food, or liquid easily. This is why we can find phthalates or the environment. Phthalate can be divided into low molecular weight phthalates and high molecular weight, shown in the slide. For the study that we have done in the aspect of EDC exposure in Thai children, the first one we try to see that how much Thai children exposed to bisphenol. From the table, as you see in Thai data, we conduct a study 2 times. The first time was in 2013, and the second time in 2019. And you can see that the detection rate of BPA in Thai children in both times were lower than the other country. But interestingly, we found the other metabolite of bisphenol that were higher than the other country. This means that maybe in Thai children, we use more for alternative bisphenol metabolite. For the phthalates metabolite detection, we conduct a study in children aged 2 to 18 and pick up some phthalate metabolite because there are many phthalate metabolites. So we pick up in some more common, and we found that the level of phthalate that we detect in Thai children were lower than the other country as well. This is the study that Professor Che mentioned before to detect the phthalate metabolite in the urine in 3 different countries in Thailand. The result is for Thai children, represented by the blue bar here. And the x-axis is the metabolite of phthalates. You can see that Thai children expose less phthalates metabolite than the other country, which is Saudi Arabia and Indonesia. That is the exposure study that we have done for EDC. For the other aspect, for the association study to the common pediatric endocrine problem that we have done, I will show you some study that we have done before. The first one is a cross-sectional study. We study on students aged 3 to 18 years. The sample size about 376 students included in this cross-sectional study, and they are collect the anthropometric data, and they need to fill out the questionnaire for BPA exposure risk and collect the urine to analyze bisphenol A by LCMS, MS. For the result of this study about BPA detection by age, sex, family income, and body mass index. As you see in the slide, for the younger age, which is 3 or 6 years, and obese children have percentage of BPA, higher percentage of BPA detection significantly. And when we calculate for the odds ratio, obesity have odds ratio of 3.4. It's statistically significant. For this study, we conclude that obese and younger children were significantly associated with BPA detection. And then we studied like a cross-sectional study to compare BPA level in common disease group in pediatric endocrine problem, which is an advanced puberty that includes central precocious puberty and early puberty, and compared to the age-matched control. And we find that this is the clinical characteristic of participant. You can see in the table, there are different for many factors by the nature of disease, including obesity. In this study, we found that in the advanced puberty girl have more percentage of girl with obese. So we divided participants into 2 groups by using BMI into normal weight and overweight or obesity. And in each group, there we have a normal puberty and precocious puberty. And from this picture, you can see that the level of BPA was higher than normal puberty in the obese group, but not significant in normal weight group. In this study, we conclude that BPA exposure appeared to be related to early onset of puberty, especially in obese girls. And we also conduct the similar study with phthalate metabolite, and we found some significant that precocious puberty associated with increased MEP concentration. This is one of the phthalate metabolite. So we interest more about the pediatric endocrine problem and EDC, which is type 1 diabetes. This is a cross-sectional study to compare the BPA level in the urine in type 1 diabetes patient and age-matched control. We collect all the data like that, the previous study, and analyze BPA by LCMS. And we also collect the diabetes data in diabetes group, which is a duration of diabetes, dose of insulin, and average hemoglobin A1C. This is a clinical characteristic of the participant. And you can see here, the urinary BPA level was higher in type 1 diabetes group compared with the control. So we conclude in the study that higher urinary BPA level is one of the possible risk factor of type 1 diabetes. For the last study that I will show you in this talk, is a cross-sectional study in students aged 6 to 12 years, about 364 students. And we collect all the data like the previous study, and also measure body composition by Tanita BC, and collect the urine to analyze phthalate metabolite by LCMS method. And this table shows you demographic data of the participant by sex, age, and BMI. And we try to separate the level of the quartile of phthalate concentration into 4 different quartiles. And in this table, you can see that the level of total phthalates was higher in male and higher in older children, but not different between normal weight and overweight. And this is the this table shows the body composition measurement of each gender. We measure the total fat mass, fat-free mass, and also we measure in segmental part. And from this table, you can see at leg part, the percent fat was higher in girl, and fat-free mass was higher in boy. But however, for the total composition, they are not different. And then we do a multiple regression analysis of the sigma phthalate concentration and body composition by adjusting by age, gender, and BMI. And we found that the fat mass has the highest adjust beta coefficient. So in this study, we conclude that higher unilateral concentration was significantly associated with elevated fat mass and were not measured through the degree of obesity that defined by BMI. So in conclusion of my talk, for the exposure study, we found less exposure to BPA and phthalate in Thai children. For association study in BPA study, we have association BPA associated with precocious puberty, obesity, and type 1 diabetes. And for the phthalates, we also found the association with precocious puberty, body composition, that the fat mass, and lipid profile that we not show in this slide, in this talk. And we try to analyze them with thyroid function test, but we cannot see any association both BPA and phthalates. In general, I think epidemiological study is the method of choice to detect the association. And when we find the association, we have to analyze to do more experiment to see the mechanism of this association by study in cell or animal study. So thank you for your attention. This is all we have data of EDC in Thai children. If you have any question, maybe we can do it in Q&A section. So we move to the last session of the meeting. It will be presented by Professor Yung Lim Ho. He's a professor of exposure assessment biomonitoring from UG University. He published more than 100 research articles in the areas of exposure assessment, risk assessment, and biomonitoring. And his research interests are focusing on identifying EDC in human biological sample and elucidating mechanism of the chemical exposure in human body. And he is a vice president of Korean Society of Environmental Health. So please welcome Professor Yung Lim Ho.
Hello, everyone. Nice to meet you.
Hello.
Thank you for inviting me and detailed introduction to such a nice meeting. I'll start my presentation. Can you see?
Yes.
Yes.
Okay. My same is biomonitoring and of EDCs in human specimens. My presentation consists of two parts. The first is biomonitoring concept and human specimens, type of biomarkers and instrumental analysis. Second is introduction to ongoing project, the biomonitoring of alternative plasticizers. Let's look at the concept of biomonitoring. Exposure to environmental pollutants occurs through different routes, such as inhalation, ingestion, and thermal absorption. Human biomonitoring takes into account all these factors by measuring the concentration of a chemical or its metabolite in human matrices. HBM, human biomonitoring, can be defined as the method for assessing human exposures to chemical or their effects by measuring these chemicals, their metabolites or reaction products in human specimens. Biomonitoring involves measurements of biomarkers in bodily fluid such as blood, urine, saliva, breast milk, sweat, and other specimens such as feces, hair, teeth, and nails. Let me give you an example of 1-OHP, a classic biomarker for PAH exposure. Pyrene is metabolized mostly in the body to 1-OHP. The metabolism of chemicals proceeds to phase 1 in which oxidation reduction reaction occurs, and phase 2 in which conjugation occurs with macromolecules. The reason for metabolism is to increase water solubility of chemicals and excrete them outside the body. Most of the metabolized and water-soluble substances are excreted in urine. The proper biomarker of these substances is metabolite in urine. The example of the 1-OHP, we determine the 1-OHP in urine, not the 1-OHPG. At the deconjugation step by the chemical reaction is the next. Blood consists of blood cells and plasma. Blood is one of the most commonly used matrices in human biomonitoring. Blood is the preferred matrix for many chemicals. Disadvantage of using blood in human biomonitoring is the need for invasive sampling. In general, chemical substances which don't metabolize well, such as PAPs and heavy metals, are mainly measured in blood. Urine is readily available sample matrices, which is easily accessible. In other words, non-invasive sampling in large volume. Urinary biomarkers are used for rapidly metabolized and excreted compounds, such as non-persistent pesticide, bisphenol A, and other phenols, parabens, phthalates, volatile organic compounds, and PAH. Problems related to urine as a biological monitoring metrics are related to the wide variability of urinary excretion, weight among individuals, as well as the great temporal variability in urine composition within individuals. Most EDCs are easily metabolized, so biomonitoring is preferred in urine. Hair samples are used for identifying long-term exposure to metal, and the hair is also used for doping tests on banned drugs. Human nails are largely comprised of keratin-rich proteins, which incorporate trace elements in proportion to dietary intake and other exposures. Use of nails for biomonitoring offers several advantages. The possibility to integrate a relatively long-term intake with the exposure of a single specimen. Specimen collection is non-invasive, and the sample shipping and storage is easy. You can see the type of biomarkers. There are 3 types of biomarkers. The first is biomarkers of exposure. It identifies the major chemical residues in tissue or body fluid, metabolites of xenobiotic compounds or physiological outcomes that occurs as a result of exposure. The second biomarker is biomarkers of effect. It reflects quantifiable changes in biochemical, physiological, or other parameters in the organism that occurs as a result of exposure. The third biomarker is susceptibility biomarker. Individual susceptibility factor is affected. It reflects intrinsic characteristics of organism that make it more susceptible to the adverse effect of an exposure to a specific chemical substances. Identified biomarkers are measured through human sample analysis. Human specimens are prepared according to the type of sample and then quantitatively analyzed using instrumental analysis. Preparation methods usually LLE, liquid extraction, or solid phase extraction, etc. For the metals, acid dissolution is used. Not metabolized VOC, volatile organic compounds, and POPs, persistent organic pollutants, are analyzed by GC-based instrument. Urinary metabolites of chemicals such as metabolite of EDCs and PCPs are analyzed by LC-based instrument. Non-targeted analysis of chemicals without standard materials are performed by Q-top mass technology or HRMS technology. Examples of instrumental analysis of EDC metabolites are as follows. Parabens, bisphenols, benzophenones, and phthalates are determined by this procedure. PCPs is other procedure is needed. The second is the introduction to ongoing project. The project theme is biomonitoring of alternative pesticides. Phthalate has properties to soften plastic, and they are mainly used pesticides for PVC and used for building materials. Evidence of correlation of human health effect with phthalate is as follows: reproductive impairment and decrease in sperm count and concentration, and etc. I will introduce alternative pesticides. DHP, this 2-ethylhexyl phthalate is a typical phthalate pesticide used in PVC materials. Because of regulation for 6 species, including DHP, in countries around the world, alternative substances for pesticides appeared, such as DHTP, it is terephthalate, and DHA, it is adipate form, and Binchi is cyclohexane form, and the TOTM, it is maltatic acid form, and ATBC, it is citric acid form, and the DIMP and DIDP is high molecular phthalate. These 7 compound is target chemical for our project. In the United States and Europe, the amount of non-phthalate pesticides usage has grown to about half that of phthalate pesticides. In Europe, low molecular weight phthalate, such as DP, DMP, BBP, DHP, etc., were significantly reduced in usage, and alternative pesticides are increasing. In terms of toxicity and health effect, alternative pesticides have relatively low toxicity compared to DHP. Korean National Environmental Health Survey result shows decrease of urinary metabolite concentration of DHP. Although not measured, it is estimated that the use of alternative pesticides has increased. This table is identified human biomarkers for alternative pesticides. The substances in the red circles are being measured by biomarkers. This figure shows the metabolic pathway of binge, isononyl cyclohexane dicarboxylic acid. This is a metabolic pathway of DHA, and it is a metabolic pathway of TOTM, trimallitic acid. The materials in the red circles are being purchased and measured in our lab, In fact, other substances are known as better biomarker, but commercially not available. In the case of ATBC, most biomarkers have not been purchased. It is not available commercially. We already prepared and validated analytical method for urinary metabolites of existing plasticizers and alternative plasticizers as follows. This table shows the urinary metabolites concentration of phthalate in Cheonan Asan panel in Korea. Total 618 urine samples were analyzed. In the median, the metabolite of DBP and DHP showed a high concentration. This table shows urinary metabolite of alternative pesticides in Cheonan Asan panel. About the alternative plasticizers, the metabolite of DHTP, DHA, DIMP, binge showed over 70% detection rate. Comparing biomonitoring results for alternative plasticizers by country can be an interesting topic for future. But until now, we cannot compare the concentration of alternative plasticizers. There are no data about the alternative plasticizers. About the existing phthalate plasticizers, total metabolite concentration is higher at Korea than USA and higher in the teenager than in 30s, from 30s to 50s. And in the USA, the metabolite of DIMP was higher and higher concentration. And in Korea, DBP and DHP metabolites were higher concentration. This suggests that there are differences in the type of pesticides used in different countries. There are many types of alternative pesticides. So we are preparing an analysis method to estimate the exposure amount by analyzing the final metabolite of the non-phthalate plasticizers in urine. There are many other non-phthalate plasticizers. And final metabolites are these compounds, and we are preparing the analytical method by estimates. Differences between environmental sample concentration and biomonitoring results are showed in the data. Left data is environmental sample, indoor dust sample data. DHP is highest, and DHTP, DINCH, ATBC, DINP is a higher concentration. You can see the median value. It is determined in the Chananasan sample at the children's urine. The median value showed very low at inch. The indoor dust concentration is quite high. The FUE value is high. FUE of OH minch is over 10%, but the concentration in children's urine is quite low. FUE value may vary from person to person, or other metabolite may be more appropriate biomarkers. About the DHA, the concentration in indoor dust is low. The FUE value is very low, but the concentration in urine is quite high. There are possible different sources of exposure, such as dietary factor. I plan to conduct further research on these questions. For example, we plan to check if there are more metabolites of binge, and we will also investigate the source of exposure of DHA. Thank you for attention.
Thank you, Professor Jung Lim Ho, for the lecture about biomonitoring. So now we are in the Q&A session. If audience have any question, you can chat in the box, and speaker will respond your question. Now we have 2 questions in the chat box. The first question, I think Professor Shade, you can respond this question. They ask that, do you see any changes in EDC exposure in the past recent years? There are increasing trend in takeaway food service with the use of plastic container and packaging. Does this affect EDC exposure?
Oh yeah, it's really a nice question from Dr. Kit Sada. I think a temporal trend is very important information for us to understand whether certain chemical exposure is increasing or not. And especially for these days, affected by pandemic, many people use delivery food, packaged food, and we can hypothesize that we may be exposed to greater amount of packaging-related plasticizers and chemicals. But the problem is understanding temporal difference over time may be influenced by population characteristics. So one time, maybe this time, teenager boys, and maybe next time teenager girls. That kind of characteristic can change many things, especially for those chemicals like endocrine disrupting chemical, which could be affected by many factors and which could be excreted from our body very fast. So one thing we can use is if we can use nationally representative biomonitoring data like US NHANES or Korean national biomonitoring data, German environmental survey, or Canadian health measure data. That kinds of nationally representative database, we can use temporal trend because the data we observe is from the nationally representative population. Another way we can do is we can just confine specific population. For example, like ladies in their 20s or like teenager school children. We just fix a population characteristic and collect the sample over time. For example, like this time and maybe 5 years from now, and we can compare. Other things are supposed to be similar because they are same age, they are same sex, and they are living and sharing in similar environment. And only difference would be, exposure to certain chemicals. So that's why we try to design a multi-country children's exposure study, and we want to collect the sample every 3 to 4 years so that we can check the difference. Another way we can tell is we can simply design an intervention study. One group of people, we ask them, keep away from fast food, delivery food, packaged food. And then we can compare the urine before intervention and after intervention. And by doing so, we can see the difference. And I'm sure there must be many chemicals involved in packaging. But as I mentioned, it may not be difficult to capture the difference if we design in a loose manner. But if we conduct a study with a well-designed structure, I think we can easily identify which chemicals are increasing. And I'm sure I agree that there must be something more we are exposed to because of the increased access to this packaged food.
Okay, thank you, Professor Che. This next question is, in addition to pesticides, do we have exposure data on other agriculture-related EDC, such as atrazine? Since agriculture is our main industry in Thailand, this type of data could be important to better assess Thai EDC exposure. I can respond this question. As I know now, we don't have any data for the EDC. For example, atrazine that you asked from Thai children or Thai adult. So we don't have that data. I think back to the lecture that Professor Che gave us, that maybe we have to start with identifying priority chemicals in Thailand. I think maybe pesticides and other EDC that related to agriculture. I think this is will benefit for us in the future. Are there any questions? Okay. If there is no any question, okay.
Hello. Thank you very much for this very interesting talk. EDC is a very new concept for me as a doctor. So coming from the UK, I just want to ask, why is there quite a big difference between the number of studies done in Asian countries compared to, say, European and in Europe and USA? Is it because of increased awareness of EDC in Korea and China and Thailand, or yeah, what's the reason for that?
Would you repeat your question? I mean, from my understanding, you're asking why in certain countries more studies are done for EDCs and certain countries are not. Is that?
Yeah, exactly. Yeah.
Yeah, I think it's a very nice question. In my opinion, in many Southeastern Asian countries, most environmental health scientists are interested in heavy metals and pesticides until recently. And I think these chemicals may be very important determinant of health in certain regions, heavily agricultural and still using a lot of pesticides. But I see the increasing amount of exposure to different types of endocrine disrupting chemicals as well. So as you mentioned, increasing awareness about the presence of other chemical risk factors kind of necessitate, force them to study more on endocrine disrupting chemicals. Pesticide and heavy metals, sometimes we cannot easily control because agricultural use is more like broad contamination. But pesticides and consumer chemicals can be like traced back to the source and easily controlled from our living environment. So I think it's easily track down the source and easily mitigate the exposure. So I think we may have a better handle to control these contaminants. And I'm sure Thailand rapidly, industrialized and developed country, I think that people are exposed to very high levels of endocrine disrupting chemicals in addition to pesticide and heavy metals. And as more studies are doing, I think you can identify priority chemicals that are associated with health in addition to pesticide and metals. And you can identify certain chemicals to work on to reduce the exposure.
Thank you, Professor Chen. Oh, okay. Sure. Okay. Oh, okay. Okay. We have a question. Could you please give more detail about situation of phthalate exposure related to asthma in Korean children? Maybe Professor Che.
Phthalate and asthma, I think it's very
yes.
specific question. I think asthma is not my area of expertise, but I know there are several studies that are going on in Europe and also in Japan and some in Korea as well, that there are some relationship between the exposure to phthalate and asthma, especially among children. Actually, phthalate and these endocrine disrupting chemicals are associated with many like respiratory and immune-related disease. And asthma, as far as I know, is one of those disease associated with phthalate. And frankly, I do not know the direct link between the phthalate and asthma in terms of like etiological link, but I know there are a lot of epidemiological studies that are done on these issues, especially those studies by Professor Hokkaido group. There are Hokkaido University. Achuko, Professor Achuko's group has published some studies about that. So I think you can take a look on that. I guess Professor Krychard has been working together with Achuko's group for many years.
Okay, thank you. The other question, different countries use the different type of pesticides. Is it by economic choice or by the national regulations? In my opinion, I think it's both of them. But maybe Professor Chet, you have any more comment for this?
I think for this, Professor Ko may have a better answer because he's running the study related to alternative pesticides. Professor Ko Young-min, would you answer to this question?
I think there are many reasons, and at different country, people use different materials, and their lifestyle is reason of the different material. And second, I think, is the manufacturer of the pesticides. In our country, big manufacturer is located, and they are manufacturing big, huge amount of pesticides. I heard from them of the total amount of the manufacture, the half of used in our country, and abroad the half is used at the abroad, and we are very close to the Chinese, and many material is imported from the Chinese, and what pesticides they use in the China is important of the source, I think.
If I can add a little bit more to what Professor Ko mentioned, he mentioned three things. Number one, lifestyle, and we found a similar observation that support Professor Ko's suggestion. Among Saudi children, we saw very high levels of pesticides, of which molecular weight is low. And those pesticides are typically used in perfume. And we heard that Saudi children, to believe it or not, are wearing more perfume than other children of other countries. So I mean, that kinds of different lifestyle in specific reason could explain the different pattern of phthalate exposure. And number two, he mentioned factory. And I think I really agree, because in Korea, we see very high levels of DEHTP and DEHA. But in Deutschland or Germany or Europe, we see higher levels of DINCH, DINCH. DINCH is manufactured by German petrochemical chemical company. So DINCH is heavily used in European country. We are using DINCH, but not that much. So depending on the chemical manufacturer, or like alternative pesticides, they are producing, we use different alternatives. We use DHTP, but US and German people use DINCH. And he also mentioned import and export. We are heavily importing the product and goods from China. So we see higher levels of compounds, chemicals that are contaminated in imported goods from China. So I think these things are all influenced. So that's why I think it's very valuable question to see the difference in chemical exposure among different countries, so that we can identify which chemicals are more important in certain regions.
Thank you, Professor Che. Due to we are running out of time, we take one more question from Indonesia. She asked that since the research related to metabolites of EDC already available, is it essential to conduct research to estimate the daily intake of EDC in the environment and human body? Actually, if you see in the journal about exposure, we have a formulation to calculate daily intake of EDC by using the level of some specimen that we have. I think we can calculate that. And the other is according to that question, is there any recommendation for Indonesia as an example? What type of research needs to be implemented first, and what EDC type based on previous study which can be found in Indonesia? I think this is a good start. We can join together to do a research in the future, and we start together. And you just leave your email address, and then we will contact you as soon as possible and do a small group discussion later on. Okay. If there are any questions, so we just thank you for all speakers and all the audience. And thank you for School Global Health to set this meeting. And Professor Suttipong, you have any comment?
So lastly, I would like to thank all three speakers. It's a wonderful talk, and all the participants for this seminar or webinar. So I'm sure that EDC is very important. It's the main concern globally, but we lack of data in many countries. So as Professor Rishit, I think he mentioned, we would like to do something forward in terms of research about the EDC and some particular diseases. So I would suggest that you may leave your email address and the name. I would like to contact of you who are interested in this research, and I will do the first focus group and do something more about the EDC and human health. So lastly, I thank all of you to join this section, and School of Global Health would like to do some more forum, and I'll let you know in the near future. Thank you.